Day 2 notes. One interesting application. Interesting, one man's opinion, I suppose. One interesting application of parametric equations involves examining the path of a projectile. A projectile is launched at a height of h0. So h0 being the initial height, at an angle with theta with the horizontal, and with an initial velocity, v0, feet per second. The path of the projectile, this may look like physics, is modeled by the parametric equations of here. Maybe most important, this set will be given to you, so you don't have to memorize those. You do have to understand what the pieces are. So v0 is initial velocity. In physics, you break that down into an x piece and a y piece. We're not going to, this sort of happens automatically here. We're just going to say v0 is the total overall initial velocity. Theta is what we often call the launch angle. So what angle we fire the gun at or shoot the cannon at or whatever, throw the ball at. Kind of just going in order here. T is time, not really worried about that one. H0, that would be the initial height. Right, that second equation should be very familiar to physics people. I think in physics we usually put the t squared first, and then the velocity, and then the initial height. But it's the same stuff. It's all there. So you'll need to replace those three things with the values given in the problem. So we'll give you the equations, but you'll have to know what goes where. Then you can use your calculator. Number 1, a rocket is launched from ground level at an angle of 80 degrees with an initial velocity of 95 feet per second. Gravity being 9.8. Well, if we're in feet, gravity is negative 32.2 feet per second squared. Physics, so 9.8 meters per second squared, 32.2 feet per second squared, and that's where the 16 comes from. So yes, you have to consider gravity, but gravity is already built into the equation. All right, a pair of equations. So x equals v0 cosine theta times t. So what's v0? What's the initial, what does v0 stand for, and what is it? 95 cosine of this one's easy because there's only one angle in the problem, 80, and then that times t. I want to write the y one before I plug it in. 95 cosine 80 times t. The y one, the y equation, h0 plus v0 sine theta t minus 16t squared. What's h0 for this problem? 0. How'd you know that? Ground level. So there's some, you might remember this from physics, there's some secret words in there that tell you things that, they're not explicit. 0 plus 95 sine 80 times t minus 16 t squared. Sketch the graph and write your window settings. Okay, well let's go to y equals first. Since it's 80 degrees, there's your answer. You want to be in degree mode. So, especially if you're borrowing one of my calculators, because calculus is always in radians, so make sure you're in degrees. Also make sure you're in parametric mode. So y equals, which really means x equals and y equals, 95 cosine 80 times t. Careful with the parentheses. Remember the T button, the X button becomes the T button when you're in parametric mode. Like that's the variable button. So the calculator knows you're used to hitting that button to get X. So hit it now and you'll get T. The X button that you usually use for X, when you're in parametric mode, it puts a T there. All right, for y equals, I don't need to do the 0 plus. I'm just going to go straight to 95 sine 80 times t minus 16 t squared. And then my window, since we're launching this thing at time equals 0, I think I can start at 0. I don't know yet what's a good t max. I'll go to 10 and we'll see what happens. I don't know what's a good x min or x max either, so I'll go 0 to 200. That may be overkill, or might not be enough. I don't know. Okay, I can clean that up a little bit. Let's see. Well, I'm going to go back and change it because this was 0 to 200 on the x direction. I bet I could get by with 100, maybe 120 just to make sure. And then on the x will be, we said 0 to 120. See how that looks. That works. It does look like you could have done 100, but you don't. Not everyone has to have the exact same. My y window was originally 200, so I think 150 probably is good enough. I'm also going to go into the negatives, and I'll show you why in a minute. So I'm going to go negative 20 to 150 for my y.
So Mr. Wolf, did you just not mess with any of the T settings?
I changed it 0 to 10, and if I needed, here's what would happen if I didn't show enough. So let's say I went 0 to 2. Whoops, I didn't see. It's like I launched the thing, 2 seconds later it's right here, and my calculator stopped graphing because I told it to stop graphing. So if that happens, like, wait a minute, I need to see more of my t. So maybe 5 seconds. See if that gets it. Whoops, not quite. All right, you throw a ball in the air, it doesn't like freeze after 5 seconds because you stopped calculating things. So 8 seconds. There we go. Good enough.
So, could you go back to your window, like how it was set? Because mine keeps on resetting. Like every time I graph it.
So 0 to 8, step of 0.1. Usually 0.1 is fine. If your step is too big on your t, then your graph is going to be like, it's not going to be nice and smooth. Like, let's just kind of get ridiculous. 0 to 8, and we'll only graph every 2 seconds. Well, that's probably not what the graph looks like. That's because it only plotted every 2 seconds and then just played connect the dots. That's all your calculator ever does. Your calculator doesn't graph because it knows parent functions. It graphs by table of values. And just like if you don't make a good table of values, if the calculator does it, it ends up with a really weird graph. You could make it even worse if you went every 3 seconds. It's like that. That is not what the picture looks like. You go every 5 seconds, see what this looks like. Like, again.
So you want it to be.
You want 0.1 is fine. If you go too low, like 0.00001, it's like I'm going to have a really accurate graph. You will have an accurate graph. Do you know what the problem with that will be?
You'll be sitting there for an hour.
Oh, it didn't even like it.
It's like you really want to do that. Always happens to me. Like a test, I'll put in something, forget that there's a value that's already.
It's going to take forever because your calculator is.
You can't X out of it. Is
thinking 0.001, 0.002, 0.003, .004. And I mean, it does it fast, but it still takes a while to...
And you can't change it. There's no
You can get out of that if you go second quit. Whoops.
No.
Second off.
No.
You can't.
Second off, it stopped thinking. There's a little thinking bar up there. Then you could go window and be like, whoops, .001, that was a little ridiculous. Let's go back to .1, and that's fine.
And then for the bottom, for the Y max and Y scale, what would those be?
So I played with it and got -20 to 150 being a good
It's gonna be lovely switching from graphic physics to
min and
this.
max.
Gotcha.
Scale doesn't really matter, but if you make it 1, that's too many hash marks. It doesn't really, it's not really helpful.
It was 1 on mine, and it was just like black lines.
It looks like a black line.
Yeah.
We don't really use those hash marks, so it doesn't really matter what your scale is.
Okay.
Sketch the graph and write your window settings. Okay, so my graph
The graph is, here's the calculators.
looks like that. My window settings. I don't need to know the scale. I just need to know T, X, and Y. So T, we went 0 to 8. X, we went 0 to 120. And this is a place where you could have slightly different answers than me and slightly different answers than each other, depending on what your window looks like. And Y, I went -20 to 150. Problem C. Estimate. Estimate. What a great word. Means we don't have to be precise. Estimate the maximum height in feet obtained by the rocket.
150, I'm guessing it's 135, 120.
Well, the maximum height would be right there. Now, estimate, I don't want to estimate it so much that it's like, oh, 135-ish? What's a way to estimate and get a decent value?
Could you go to table?
You can go to trace. Table would work too. I'm going to go to trace. And then I can just... Now, if we have different window settings, we might get slightly different answers here. So I'm just kind of scrolling around waiting for my Y value to be a maximum. So 136.7. Whoops, and it goes down.
75.
So 136.8. Feet. 136.8 feet. Again, if you have a different calculator or a different window, your max might be a slightly different than that.
Okay.
Approximate the range the rocket travels.
Understood already.
So yeah, now we're still tracing. We just want to see where it lands now.
I'm gonna guess 96. Guess I was gonna go. Oh, I'm gonna skip it 195.
And so I want my Y value to be as close to 0 as possible.
Real nice.
Oh, I don't really get a good, right? That one's Y is 4. The next one's Y is -4.
When is our test in
Our test in this unit is next Tuesday.
So just like 96.
So I think what I'm going to do is I'm going to just sort of ballpark average those two,
Average one? 96.
right? Because that's at Y equals +4. That's Y equals -4, -5.
96.
So the X value is in between there, in between 95.7 and 97.3. So 96 point something. Sure.
What if we just put 96 in?
Is that fine?
I think I would be okay with that.
Okay.
I think probably my key would probably say anything between those two. Because if you pick something less than 95.7, then
Technically, it's still
you
you messed up on the graph. Like you could have gotten closer. So it's somewhere in between there, and our calculator. Oh, there is one way to get a more accurate answer. We're not going to do it.
Didn't you do 0?
What's that?
Didn't you like how we did on the last graph when we would find 0?
Okay, so one hope is to do calc 0, but if you go second calc,
Oh.
you don't have that option.
Is it just
Okay.
because?
So that's a great thing to remember, but it doesn't work for parametric.
So the calculator knows it's parametric just by the equation, no extra settings, right?
Well, the calculator knows it's parametric because you changed the setting to parametric. Now, there is a way to get this trace to work better.
What if you just changed it back to normal and see what happens?
If you change it back to normal, you're going to lose those equations because it's not going to be x and y anymore. So I'm still looking for a way, if I wanted to get a more accurate answer, do you know what you could do?
Change your scale.
You could change your window. You could like zoom in on that. In fact, you could just hit zoom. I don't want to do it because then I got to go change everything.
I didn't mean like that. I meant like.
But you could zoom in, and you could zoom in way zoom in so that your answer was accurate, super accurate.
I meant going.
I don't want to do that though. Estimate how long in seconds it takes for the rocket to hit the ground.
5.8.
So that's right where we were.
Between 0 and 8.
5.85.
And we're looking at T. Yeah, somewhere between 5.8 and 5.9. So how about 5.85?
So why couldn't we use a table?
You could. You could certainly use the table if you knew what you were looking for. Although the table's only going by ones.
0.1.
Another way we could get a more accurate answer is if we change that
Yeah.
T step to something smaller. But the trade-off is then it takes forever. So
Well, you just go straight to your table though.
you could go 0.05 maybe.
Or if you wanted to look exactly where it is, you just go straight to a table. Look for X or Y is 0. Right?
But yes, you could go to your table, but you're not going to get y equals 0 exactly there.
We're gonna get close.
You might get closer.
But
Here's the other problem with, I picked a narrower time step, a smaller time step. It takes forever to trace now because I got to hit all of those points. So I'll get a more accurate answer,
But it'll take long.
but it's taking forever to get there. We'll see how close 5.85 was.
Still doesn't get it.
Still not exactly it, but it's closer than either of the others.
So it's slightly less than 5.85.
And that does make our 96.5 feet look like a good answer as well. So you kind of balance those things. You don't want to take forever to watch your calculator graph something. Number 2. An archer releases an arrow from a bow at a point 4 feet above the ground. The arrow leaves the bow at an angle of 25 degrees and an initial speed of 200 feet per second. Write a pair of parametric equations. So x equals 200 cosine 25 times t. Y equals, that was the easy one. What's h0 for this one? 4 plus 200 sine 25 times t minus 16t squared. And since they're all kind of the same, this should be an easy fix on the calculator. Careful with if you use the insert button, you can save yourself a little bit of time. Oh, I almost forgot to put the plus 4 in there. 4 plus 200 sine 25 times t minus 16t squared. Graph.
Oh.
The. So what do I need to change?
Change the Windows X to a lot more.
I need to change the Windows X to a lot more. That's a great answer. I was going to go 500. That might be overkill
You
though.
need way more than that.
Oh, 500 is still not enough.
1,000.
It does look like it reached its peak on the 500,
It's barely
so
at 1,000.
maybe 1,000 is the better.
It's pretty close to 1,000.
And then I'm going to change my X scale just so I don't have a ton of hash marks down there. Okay, that looks good. And my Y values, that's fine. If you want to tweak it a little bit, you can, but I think it's fine. Be careful when you draw it. It started at a height of 4, so it did not start at the origin. So I still went 0 to 8 on time. 0 to 1,000 on X. And negative 20 to 150 on Y.
How do you get to this part where you like notes, like do the graph, like numbers, it's like point line.
Like trace?
Yeah.
Push the trace button.
No, like how do you get to the like part where you change the window? Oh, okay.
Got it?
Right. Yeah, I just forgot what button.
So you answer the next two questions. We'll see if we get the same thing. Approximate the maximum height and the horizontal distance. I don't get y equals 0 for this one, but 2.5 is a lot closer than negative 6, so I'll go with the 960. But it's probably going to be more than that. But I don't know how much more than that. Between 960 and 978. Now, if you zoomed in or you did a different time step, you could get a better answer. But I didn't want to take forever to watch it graph and to scroll over there.
So, wait, so why would you put 960?
Well, because that's a 960 is a lot closer. My y value is 2.5. If I go to the next one, the y value is negative 6.
Okay.
So it's not 960, but it's closer to 960 than 978.
If you trace over in that mode and then go to Windows and change your schedule or your rate thing, does it stay over there and you can just move it a little bit?
Oh, I see what you mean. Can I change my... I don't think so. I think it's going to graph it from scratch again, and I'm going to have to scroll all the way over there. You could go to table, and then table set, and you could do ask your independent variable. So I could try. Oh, but I would need to know what that time was.
It's 5.3.
So I could play around and say, well, I need to be a little bit more than 5.3.
Ask independent or ask dependent?
Ask independent. 5.3 to 5. So you could play with it if you really wanted to get it. 5.33. That's pretty close. So you could play with it on the table. I don't need you to play with it that much. You could play with it by zooming in. I don't need you to play with it that much. I'm going to be looking for a range of answers that will be acceptable. Number 3. The baseball is hit in Minute Maid Park at a point 3 feet above the ground. H0 is 3. It leaves the bat at an angle of 24 degrees. There's my launch angle. With an initial velocity of 92. Heading toward left center field, where the 25-foot wall stands 375 feet from the plate. I don't know why. Oh, I do know why we need that, because 92 miles per hour, we need to change that to feet per hour, or feet per second is what we really need to change it to. 92 miles per hour. Train tracks from chemistry. This is the only good part of chemistry, because you could do it without knowing what's going on.
Oh, yeah.
Like, you don't need to understand Gibbs free energy to calculate it. You just make the units work. Let's see. 1 mile is 5,280 feet. And how about hours?
Wouldn't
And
it be easier to divide by hour before feet?
1 hour is... the calculator's going to do it all anyway, so...
Yeah, I guess.
So 92 times 5280 divided by 3600. 134.933 feet per second. Now my units are right. So my x coordinate 134.933 cosine 24 times t. Y coordinate, well, we start at 3 plus 134.933 sine 24 t, and then minus 16 t squared. I guess the good news is if you really messed up something on here, you would notice it when you went to the graph. It wouldn't look like a parabolic path.
Would it always
You really
be
messed it up.
a parabolic path?
It is for us because we're always going to have a minus 16t squared at the end.
Okay.
Let's see. How accurate do we want to be on this one? Well, you know what? If we're checking to see if this clears the wall or not, we better be accurate. 134.933 cosine of 24. 3 plus 134.933 sine of 24 minus 16t squared. I can rearrange my window again because I don't need to go out however far we went last time. In fact, how far do I probably need to go out for this problem?
375 feet?
Probably 375, and maybe I want to go a little further to make sure I can see everything, but let's go to 400.
Oh,
No, 375 does not
it goes over.
And then
It needs to be
Oh wait,
above
no, it gotta
one.
be up above 25 feet.
I'm going to change my Y window as well. I don't need to go up to 150. Maybe 100 would work. Yeah, there we go. I could lower that again, but
It needs more than 420.
Wait, what'd you plug in for Y?
Oh, we got an issue. It doesn't go over the wall.
negative 20 to 100. I mean, is that an issue or is just...
Depends on what steam you're on.
I guess so, yes. Does the ball go over the wall? Explain, why or why not? So when x is 375, are we going to be close enough to know here? I can't get to exactly 375. Is it close enough to know, though, I guess is the real question. So let's see. When x is 360 or 369, y is 23.6. The next one, when x is 382, y is 19.4. And what I want to know is when x is 375, if the wall is 25 feet tall, No, I don't know what it is. It's between 19 and 23, but it's not more than 25. So the answer is no, and that's my explanation. Again, if you want to zoom in so that you can get x equals 375 and figure out where the ball is, change the angle to 25 to just change the outcome of the at-bat. Well, this is an easy fix. Go change it to 25. I'm going to go change my angle by 1 degree. Okay, second trace. Go out to 375. And again, we may have to do that thing where we're close enough. Uh-oh, I don't know if we're close enough or not.
No, it's less than 25.
No, it's more than 25. At 366, it's more than 25.
I think you said 375.
At 379, it's more than 25.
No, then you.
So I don't know exactly where it is, but it's more than 25.
That's assuming that the field's completely flat, and that's not 25 feet from that point.
Yeah, I mean, it assumes a lot of things. No wind, whatever. So yes, it's a home run with a bigger launch angle.
If it was at 45 degrees, it'd be the optimal angle.
Would it be
Maybe. Yes.
the optimal angle?
Yes. Because it gets.
I think that's going to be too high.
Actually, no. I think it is.
There's your optimal. There's 45. What in the world? Did I do something wrong?
No. 45.
Guys
is-
skied that ball. I think 30 is actually the optimal angle. Anyway, your assignment is worksheet 2. You got a calculator though, so it's just about playing with buttons, figuring things out.
45